right, so we're going to solve inequalities by either adding or subtracting today. We've talked about what's called inverse operations, and those undo the operation in an inequality. Okay, so that means if there's addition, what do we use to undo addition? Yep, so if it's addition, you're going to use subtraction, and then vice versa. Okay, so this is just a property box. You probably, when you had different textbooks, okay, they just are giving you examples of how to do addition and subtraction with inequalities, but we're going to do some together. So we're going to solve each inequality and then graph the solutions. So just like with equations, whenever you're solving for a variable, when you're deciding whether to move the 1 over or the 10, it's always what is next to the variable. So if it's plus 1, how do I move that over? Subtract 1. Okay, so just like we had with the equations, okay, this is the line, so this is each side. So you would have S, this stays the same, and then 9. Okay, so your final inequality, this is red, S is less than 9. So remember, if there's no equal to, what type of circle do we have? An open circle. And then on your number line, I just want you to put at least 3 numbers on there. So 9, you could put 10, 11, you can do 8, 7. I just want you to have 3 numbers, including the one that you have to use, okay? So I have an open circle at 9. If the numbers are less than 9, is that going to be numbers like 8 and 7 or 10 and 11? What numbers are less than 9? 8 and 7. So it has to go to the left. And then last week we also talked about, look at this symbol. Do you see how that symbol is the same one on the arrow? So that can help you make sure you're going in the correct direction as well. All right, now the next one is a decimal, but we're still doing the same process, right? So again, let's look and see where the variable is. The variable's on this side, but that's okay. We still just have to do the opposite. So if this is a negative, we're going to add 3.5 to both sides. And then, will you guys add that with your calculator? Or even without your calculator, when you guys are adding and you have 0.5 and 0.5, what is 0.5 and 0.5? Yep. So if I'm adding those up together, okay, the 0.5 and 7.5 would make 8, and then what's 8 plus 3? Yep. Okay, so you're going to have the 11 there. And then remember that when you're writing this out, you want to have the variable on what side? We talked about this last week. Do we want the variable on the right side or the left side? Yep. So if we're going to put the variable on the left, all that means is we are going to switch. So Q is here, 11 is here. And we talked about the alligator, right? The alligator eats the bigger number. So if the alligator is eating Q, we still want it to do that. So we're just going to flip the sign. Okay, so we're just going to flip it. Now the reason why we do that, and again, I like to put my whatever my number is in the middle. So like this is 11, 12, 13, 10, 9, 8. Okay, then this is going to be a closed circle because you have the equal to. Okay, so it's closed anytime there's an equal to. Okay, if there's no equal to, that's when you have an open circle. Okay, so if it's greater than, it's all the numbers that are bigger than 11. And then again, you can check. See how the arrow is pointing in the same direction as your symbol? I think that's a really simple way to check to make sure that you have that. Okay, now with this one, when you guys are subtracting from both sides, you're always subtracting on the same side as the x. So we're going to minus 3.5, or sorry, 3/5. And then there's two different ways you can do this on your calculator, so we're going to do this part together, okay? So we're going to do 7 minus, and then one way you can do this is you can put this in your parentheses, and see how it gives you a decimal, but it's a nice decimal, okay? It's perfectly fine if you leave it like that. Okay, so we're going to do x is greater than or equal to 6.4. Okay, now I know that some of you like the fraction key, so if you wanted to do 3 ABC to 5, they would give that to you as 6 2/5, and you could write that as well. So you could do 6 is greater than or equal to 6 2/5. That would be fine. Okay, so either one of those would be fine. Okay, so this would be 6.4. And really, if you have a decimal and you want to put a few more numbers on there, you could just make this 6.5, 6.6, right? 6.3, 6.2. You could make it so that it's simpler to label for you. Okay, and then what kind of circle are we going to have for this one? Is it going to be open or closed? Good. Okay, so it's going to be closed because you have the equal to. So we're going to put it right there. So this says x is greater than 6.4, and again, because it's on the left, we know our arrow is going to be going this way. Okay, nice job. All right, let's flip it over. Okay, so we got really good at problem solving in our last section. So we're going to go over how to solve with inequalities. So we're going to do a sports application today. Josh can bench press 220 pounds. He wants to bench press at least 250. Good for Josh, because Miss Whipple can bench the bar, and that's about it. Okay, so will you guys either box in or highlight that at least? Okay, so if he wants to bench press at least 250 pounds, okay, does that mean that he could bench more than 250 or less? If it's at least 250. He could do more, right? He has to get at least 250. Whenever you see at least, that is going to translate to a greater than equal to sign. Okay, so anytime you see at least, it's going to be a greater than equal to, because he can do more than 250. Okay, and then it says to write and solve an inequality to determine how many more pounds he has to lift to reach his goal. Okay, so this example was set up for you. So it's 220 pounds plus how many more he needs, and then is at least, that's your greater than or equal to sign, 250. So if you set that up, you can just subtract 220 pounds. Okay, so he has to at least lift 30 pounds. Okay, to reach his goal, because he can already lift 220. Okay, so that example was done for you. We're going to do example 2 together. So it says the recommended dietary allowance of iron for a female in Sarah's age group, 14 to 18 years, is 15 milligrams per day. Okay, so let's box that in, the 15 milligrams. She has already consumed 11 milligrams of iron today, and then we're going to write and solve an inequality to show how many more milligrams of iron she can consume without exceeding that recommended daily allowance. Now, a lot of you already even probably know by looking at these two numbers what's going to be part of our solution. Okay, I think the trickier part is going to be setting up the inequality. So if they recommend 15 milligrams per day, all right, that means that's the most amount allowed. Okay, so the most amount allowed is the 15 milligrams. Okay, she already has 11. We just have to figure out how many more she needs. Okay, so she has 11. We have to figure out how much more milligrams she needs to reach the daily goal of 15. So because 15 is the most amount, 15 is greater than or equal to 11 plus x. This is how many she has. This is how many she needs. Okay, so to solve this from both sides, I would subtract 11. What's 15 minus 11? 4. Okay, so to reach her daily goal, she has to get 4 more. Okay, so x is less than or equal to 4. All right, now the next one might be something that you calculate when you're in English class. I know whenever I had reading homework, I would always try to figure out how much more I had to read. Okay, so Eleanor must be in an advanced class because she needs to read at least 97 pages of a book for homework.
A lot of pages.
I know. Eleanor must be in college. Okay, so if she needs to read at least 97 pages of a book for homework, and she's read 34 pages already, we have to write and solve an inequality that shows how many more pages P she must read. Then we're going to graph our solution on that number line. Okay, so how many pages has she read? 34. So if she's read 34, we know 34 plus P, that's how many she has to read in order to get to 97. So if she has to read at least 97, okay, she could read more than that, but 97 is the least number that she could have. Okay, so 34 plus how many pages? Whatever she reads has to be at least 97. Okay, so we're using the greater than equal to when it says at least. Okay, and then to solve this, you would just subtract 34 from both sides. And sometimes I'll just do this the old school style. 7 minus 4 is 3. What's 9 minus 3? 6. Okay, and then check it with my calculator. Okay, so if I'm graphing this on a number line, okay, and 1 is not provided for me, I just have to draw my number line. I can put 63 here, and then I said you just have to put at least 2 more pages, okay, or 3 total. So you just have to write 2 more. So 62, 63, 64. Okay, so you have a closed circle, and then you just have to pick which way the arrow's going. Again, the arrow should always match this symbol, and if P is greater than 63, it needs to go towards the number that is greater than 63. Okay?